morning, my dear students. Already 4 minutes over, but an issue. Let me get others to join. So in today's class, I want to switch over to the module 4. So in the last classes, I just was discussing module 2, so where we discussed the system drives and actuators, and only a part of that has been left out uh, for time being. So only the hydraulic systems. So I will going to cover those things in the later part. Okay. So first I want to cover module 4 because it is a little bit very important for you people as well as uh, very important for the examination point. Okay. So in today's class, we will go into just switch over to the module 4. Okay. So module 4, so we have to discuss. I'll just share that. In module 4, we have to discuss two important things. One is called nanomaterials, and second one is characterization techniques. See, when we just look at this topic here, nanomaterials and characterization technique, it is a new concept for you people. Might be nanomaterials, might be in your uh, material science or material science. So in this concept, what we are going to discuss is the nanotechnology. Nanotechnology means, so what is the technology behind obtaining the nanomaterial? In the sense, so what is the different synthesis process or synthesis methods which is available for us to get the nanomaterial? And once you get that nanomaterials, so things will go for characterization techniques. So characterization in the sense, in order to study the distribution of the particles and the microstructure of the particles, each and everything with respect to the nano size, we will go into understand or we will go into determine, we will go to just detect how these particles have been distributed among the materials. So this is the characterization technique. So here we just quickly just discuss what we have a complete syllabus in this module 4. One thing is nanomaterials. So first thing we need to understand the nanotechnology, the definition of nanotechnology. So where we need to discuss the different methods, what we call it as bottom-up approach and top-down approaches, and what is the challenges that is there in our nanotechnology part, right? So and also we are having the synthesis processes. So what are the different methods we are having in the nanotechnology and different methods. So processing, what we generally call it as nano processing or processing methods. So once you understand how to process the nanomaterials, the later part we will just switch over to the characterization technique. In characterization techniques, so we have different methods are available for us. So we have to get what is AFM and what is XRD method and what is STEM, that is scanning electron microscope and transmission electron microscope. So there are plenty of characterization techniques they have given. So each technique we need to discuss in detail. So what is the basic principle behind that technique and what is the procedure that needs to be employed for obtaining the characterization for nanomaterials, as well as what are their advantages and limitations, and finally the application. So all these things needs to be discussed for each and every technique what is specified as like an AFM or an XRD or IRAX, or we have what we call it as STEM, that is scanning electron microscopy and traveling electron microscopy, transmission electron microscopy. Like that, there are so many different techniques they have given. For each one, we need to discuss in detail. So this is a very important topic. That's why I have chosen this. Okay. So we're going to start this module 4 today. Okay. So where it is totally purely a theoretical chapter. So concepts are theoretical based and concept based. Okay. So you need to understand the different processes, their principle, their operation, and there we need to understand the schematic representation of each processes or synthesis processes, and we need to understand, we need to draw the diagram of a scanning electron microscope, transmission electron microscope. Like that, there are plenty of sketches and involving the concepts which should be understood. Okay. So today we will going to start with the module 4. So let us start with the first part of the module 4, where we need to discuss the nanotechnology and the processing technology. And later I go for characterization. Okay. Yeah. The first thing is the two important words throughout our concept of nanotechnology or nanomaterials and characterization technique is nano and technology. So what actually you understand by the word nano? A nanometer. A nano is nothing but a meter, is a unit of length, is a unit of length in the metric system equal to 1 billionth of a meter. 1 billionth of a meter. So we call that as a 10 to the power of minus 9. Nanometer. Nano means 10 to the power of minus 9. So this basically the nano is a metric unit which is used for measuring the length. And this nanometer is equal to 1 billionth of a meter, or we can call it as 10 to the power of minus 9. Just understand. So we have micro level, we have the micro, we have over, now we are just landing into the nano. So it is 10 to the power of minus 9. What do you mean by technology? Technology is the making, usage, and knowledge of tools, machines, and techniques in order to solve a problem or perform a specific function. So why I'm talking these two words here is, so we just club together the word nanotechnology, and then we need to have the definition for a nanotech. So nanotechnology is nothing but it is making, usage, and the knowledge of tools, machines, and techniques. So whatever the available tools, machines, and techniques, we need to know how to use those techniques, use those machines, or use those tools, or we can sometimes we need to make those tools, machines, and techniques. So what is the purpose of doing that is to understand or to solve a problem or perform a specific function. So this is what we call it as a technology. So now, when these two words have been given the meaning, then it comes to the definition of a nanotechnology. And nanotechnology is the study of manipulating matter on an atomic scale. So what actually this technology means? In this technology, basically, we need to study how we can manipulate the matter. How we can manipulate the matter on an atomic scale. In the sense, if the atomic level is in the micro level, and how we can convert that into a nano. So what is the technology that we need to be studied to convert that atomic one scale or one atomic level to the another atomic scale from micro to nano. So this is what the technology is for. And it also refers to the constructing and engineering of the functional systems at a very micro level, or we can say at atomic level. So means it also refers to the constructing and engineering of the functional systems at very micro level. In the sense, so we need to have constructing and engineering. In the sense, when you want to do any manipulations or any modifications, so that for the functional systems, and we are talking at the atomic level. Atoms. So we are just discussing with respect to the atom level. So it is a very minute part of any matter, right? So the technology which refers to the constructing and engineering of the functional systems, which are at a micro level, or we can say at the atomic level. So this is what we call it as a definition of a nanotechnology. It's the study of manipulating matter on an atomic scale. A nanometer is a 1 billionth of a meter, roughly the width of three or four atoms. The average human hair is about 25,000 nanometers wide. Imagine here. A nanometer is a 1 billionth of a meter, roughly the width of three or four atoms. The average human hair is about 25,000 nanometers wide. 25,000, just imagine the hair, human hair. So it is the width of a human hair is 25,000 nanometers. So if we are talking about just it is so minute, the hairs are. So that is the width of the hair itself is 25,000 nanometers means just imagine what is this 1 nanometer. Okay, so you are getting into the minute level or what we can call it as nano level. You are getting into the atomic level. So when we want to study how we can manipulate the matter across the atoms or across an atomic scale. So this is what we generally call it as the nanotechnology. Okay, this is just what we are showing here. This is just like in the form of a carbon tube or the shells, what they have shown. This is the structure of a nanoatom. Okay. Now, once you understand what is nanotechnology and what is the meaning of the two words, nano and technology, next comes how this technology has been developed. Means what is the history of the nanotechnology? There is a one quote, what we call it as Dr. Richard P. Feynman is given, there is a plenty of room at the bottom. So it means, so still just discussing at the surface level or at the micro level. So what it says is you can go till depth, you can go up to the bottom, and at the bottom you have a lot of things can be manipulated. So we can use the tools, we can use the technology so that we can bring or we can change the structure across the atomic level, the bottom, or we say room at the bottom. Room at the bottom is the bottommost component in our matter is an atom. So we have the technology, there is plenty of room at the bottom. So we have plenty of options where we can study and where we can manipulate the atomic structures of an atom so that we can impart or we can obtain required characteristics for the given matter. This is what the statement what that Dr. Richard P. Feynman has given. He was the first ever person who has been given the concept of nanotechnology, and it was in 1959 with Dr. Richard P. Feynman, and basically he is a professor in physics. Invention of the scanning tunneling microscope in 1981 and the discovery of Fullerene C6O in 1985 lead to the emergence of nanotechnology. So the basis for the nanotechnology is the two inventions. One is called the scanning tunneling microscope, which is in 1981, and the second one is the discovery of fullerene, a chemical compound, in 1985. So these two inventions of scanning electron microscope and discovery of fullerene leads to the emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. In 1974 only they are given the name as nanotechnology. But the full concept of nanotechnology has been developed only after 1985. Okay? So this is the basic history of this. Is the person what the picture what it is showing. The person is a Dr. Richard P. Feynman. He is, we can say, call it as the person who started the first concept of presented the first ever concept of nanotechnology. So the early 2000s also saw the beginnings of commercial applications of nanotechnology, although these were limited to bulk application of nanomaterials. So of course, in the early 2000s, so there is a they are started using uh, nanotechnology and applying the nanotechnology for various purposes, especially for bulk applications of nanomaterials. Silver nano platform for using silver nanoparticles as an antibacterial agent. Nanoparticle-based transparent sunscreens and carbon nanotubes for strain-resistant textiles. So this is what they are giving here is silver nano platform for using silver nanoparticles as an antibacterial agent. So this is what the development of nanotechnology. So where they use for antibacterial agent. So they are using the silver nanoparticles as an antibacterial agent, and also they developed nanoparticle-based transparent sunscreens and carbon nanotubes for stain-resistant textiles. Stain-resistant textiles. So this is what the development of nanotechnology for making the different nanomaterials. And of course, it was limited only for the bulk applications. That's it. Okay, and that is it is happened in the early 2000s. This is what the history or the evolution of what we call it as nanotechnology. You can see here the you can see here the difference between macro, micro, and nano. So how we are just going about it. The macro, a person 6 feet tall is a 2 billion nanometer. Is it 2 billion nanometer? Just imagine 2 billion nanometer. Apple 8 centimeter, 80 million nanometer, and 5 millimeter, 5 million nanometer. This is what we are talking about. How we used to have the measurements in the macro level. And later part, we just switch over to the micro. So what we are just comparing here, how the technology has been evolved. Initially it was a macro, now then we switched to the micro, now we are at the nano level, right? So how the technology have been switched from the macro to the nano level. Okay, so this is the we are getting into the bottom of a matter. That is what they have. There is a plenty of room at the bottom. So we are getting into the bottom of a matter. So means we are using the technology to modify or to manipulate anything across the atomic layer. So that is what the technology, what we call it as a nanotech. So when you look at this slide over, the different technological level, macro technology, micro technology, and nanotechnology. So their comparisons they have given over here. So macro means it is the height of a person, or this 2 billion, 2 billion nanometers, whereas Apple 80 million nanometer, whereas an ant, which is of 5 millimeter, and it is of 5 million nanometer. And when it comes to the concept of micro, so let's just look at it here. The diameter of a human hair, it is 75,000 nanometers. Smallest, the eye can see. It is 10,000 nanometer, smallest. Okay. So then we have the E. coli bacteria. It is a 2000 nanometer. So these are all the corresponding data across the micro level. It is across micro level. So now we are moving into the latest technology, what we call it as a nano technology. So where you can see here, Bucky ball is 1 nanometer, 1 nanometer, DNA, which is 2 nanometer, 2 nanometer. Diameter of a carbon nanotubes is 1.3 nanometers. So just moving towards the bottom, the depth of a nano. So the technology we have just using and we have evolved and we are using this technology, nanotechnology, so that we are getting into the minus or minute of the particle, what we call it as an atom or atomic level. This is what the comparison, what we can make with macro, micro, as well as nano. Hope you people are following because it is totally, it is a different topic from than what was studied till now. Okay. So because of course these things you might have been studied or discussed in material science, but it is not to this depth. Okay. So you are getting into the depth of the concept of nanomaterials, nanotechnology, characterization. So wherever you have any clarifications, wherever you find any doubts, you can stop me and you can just talk. Okay? Now we have just a simple definition of nanotechnology. And nanotechnology is a fundamental enabling technology allowing us to do new things in almost every conceivable technology discipline. Means, so what they say is, this is the technique which we are using, which we are using or allowing us to do. We are allowing us. Yeah. So basically, a nanotechnology is a fundamental enabling technology allowing us to do new things in almost every conceivable technological discipline. Nano means, of course, I told you it is a 10 to the power of -9 meters, but of high potency, but emerging with the large applications, piercing through all the discipline of knowledge, leading to industrial and technological means. A technology is a fundamental and enabling technology. So from this technology, we can do new things. New things are almost every conceivable technological discipline. Conceivable means which you can easily to obtain because whatever the disciplines, technological disciplines are there, so we can go up to, we can use the technological disciplines and we can able to do the new things. Okay? So of course, this nano is having a very high emerging aspects with the large applications piercing through all the disciplines of knowledge, leading to the industrial and technological nanotechnology comprised of? Basically, this technology is comprised of nanomaterials with at least one dimension that measures between approximately 1 and 100 nanometers. So, till now, what we are talking about it is what is nanotechnology, what is the history of nanotechnology, and just the definition of nanotechnology. So now let us just move on to what is nanotechnology is comprised of. So the most important thing, the nanotechnology is comprised of the nanomaterials. So nanomaterials in the sense, so it's supposed to have, these materials supposed to have the dimensions that measures between approximately 1 and 100 nanometers. 1 and 100 nanometers. Second thing is, it's comprised of nanomaterials that exhibit unique properties as a result of their nanoscale size. And also, this technology is comprised of nanomaterials, so which exhibits the unique properties. So means it will have special properties, and that is because of their nanoscale size. In the sense, the particles will have or they can exhibit the special properties, the unique properties, which you can exhibit across the nano level, not rather than across the micro level or at the macro level. It is the giving or exhibiting its unique properties across its nano level. So such materials have been involved in the nanotechnology. And also, it is based on new scale discoveries across the various disciplines of science and engineering. The manipulation of these nanomaterials to develop new technologies / applications or to improve on existing. This nanotechnology is based on new nanoscales. So scales is different for this. And across, of course, various disciplines of the scale in science and engineering, whether it is in physics or in chemistry or in engineering, whether it may be mechanical or maybe electrical or civil, whatever it might be. So they have the technology is based on the new scale discovery. So each one they will be keep on discovering the new scales, and of course it will going to be across disciplines of various disciplines of science and engineering. And also this technology involves the manipulation of nanomaterials to develop new technologies or applications or improve on existing. And of course, this technology is also involving manipulation of nanomaterials. The purpose of manipulation is to develop new technology or applications or to improve the existing. In the sense, the nanotechnology involves the manipulation. It needs to change. If anything needs to be changed across the nano level in the nanomaterials, and the manipulation is to be done to develop new technology. So we need to have new technologies or applications or to improve the existing. And it is used in a wide range of applications from electronics to medicine to energy and more. So the nanotechnology is used in the application of nanotechnology is plenty, is a wide range. So we can start from electronics to medicine to energy, and of course, we are going to discuss those things later. Nanotechnology is the creation of useful or functional materials, devices, and systems to control of matter on the nanometer length scale. So what they say here is the nanotechnology means creation of, it creates the useful functional materials, devices, and systems through the control of matter on the nanometer. In the sense, so by controlling the matter, controlling the matter across the nanometer length scale, so Using the nanotechnology will go into create the useful functional materials as well as the devices and the systems, and also this technology exploits a novel phenomenon and properties which arise because of nanometer length scale. This is what I was talking in the previous one. Some of the materials they exhibit the unique properties across the nanos, which they may not be exhibiting across macro or micro. So from this technology, we can explore or we can exploit so which properties that the material can exhibit across the nano level. This is what they are saying, the exploitation of a novel phenomenon and property. Novel phenomenon, because some of the phenomenon will be taking place at the nano level, which you cannot obtain, you cannot reveal across the micro or macro level. So you can exploit what are the novel phenomenon across are occurring across the nano level, and also what properties that the unique properties we can say that the materials can exhibit across the nanometer scale. This is what the nanotechnology. Okay, you can create the useful or functional materials, devices, and systems. So how we can do? You have to control the matter across the nano length scale, and also you can exploit the novel phenomenon and the properties. This is what we call it as the nanotechnology. I hope you people are following because little bit of a new concept for you, so you need to understand this in a very clear way. Next comes the emergence of nanotechnology. So how it has emerged, of course, history we have already been seeing, and of course another one topic which is in the form of an emergence of nanotechnology. I'm just going with respect to your syllabus. The emergence of nanotechnology has led to the design, synthesis, and manipulation of particles in order to create a new opportunity for the utilization of smaller and more regular structures for various applications. See, when the nanotechnology has emerged, so it has led to the design, synthesis, and the manipulation. Design, synthesis, and manipulation of particles. So what is the purpose of design, synthesis, and manipulation of the particles? Used to create new opportunities for the utilization of smaller and more regular structures for various applications. So before the emergence of nanotechnology, we might not be knowing what applications these materials are having. Of course, they might be used for some other applications, but some materials will have their unique properties. They can exhibit the unique properties across the nano level, and because of the properties, it can be used for some other specific application. So that we are not knowing before the emergence of nanotechnology. This is what they say. There are few materials which can exhibit a special properties across the nanolevels, and these properties can be used for making or using for the different applications or special applications. So that you can exploit, okay, by using this nanotechnology. So it will create an opportunity for, we'll say, create an opportunity for utilization of. So because until unless we know this is the material can exhibit this property at this particular scale, so we don't know how to utilize it. So once it is being exploited, once you can have the control over the matter, once you know how to manipulate the particles across the nano level or across a different scale, then we have an opportunity to utilize those smaller and more regular structures for various applications. This is what the emergence of nanotechnology has given for us. Okay? In recent years, nano-sized metal oxide particles have gotten much attention in various fields of application due to unique optical, electrical, magnetic, catalytic, and biomedical properties, as well as their high surface to volume ratio and specific affinity for the absorption of inorganic pollutants and degradation of organic pollutants in aqueous systems. This is one important thing. See what happened with the emergence of nanotechnology. They have uh, discovered the nano-sized metal oxides, the nano-sized metal oxide particles. And these nano-sized metal oxide particles have very much applications in its unique optical, electrical, magnetic, catalytic, and biomedical properties. These nano-sized metal oxide particles will have its unique property, which has given applications for the various fields, especially in optical field or electrical field or magnetic or catalytic and biomedical properties, as well as their high surface to electrical or high surface to volume ratio. In the sense, when a metal oxide particles across a nano level, when it exhibits its different properties, just like an optical properties or electrical properties or magnetic properties, and of course catalytic and biomedical properties. So this is all of the properties which they have exploited. So and they come to know at nano level how these metal oxides can exhibit these properties. So the exhibition of these properties has been utilized for various fields of application. This is what we are just talking about. So these are the properties: optical, electrical, magnetic, catalytic, and biomedical properties. So this you might not be known across the micro or macro. So these properties, these materials or metal oxide particles, when they exhibit these properties across the nano levels, and we can utilize those properties for various fields of application. This is a very important use of application of a nanotechnology, as well as their high surface to volume ratio and specific affinity for the absorption of inorganic pollutants. This is very important. The surface to volume ratio is very high, and specific affinity for absorption of inorganic pollutants and degradation of organic pollutants in aqueous systems. See, these are all the physical properties what I am talking: volume to specific surface to volume ratio, and their chemical property, that is especially a specific affinity for absorption of inorganic pollutants and the degradation of organic pollutants in aqueous systems. In the sense, the emergence of nanotechnology has given plenty of opportunities for us to utilize the properties, the unique properties that the material can exhibit across the nanoscale. So, making use of those properties, we can use it for various applications, various fields of application. This is what the emergence of technology, emergence of nanotechnology has been benefited. Right? Yeah. So we are talking about the definition or history or emergence, whatever it might be. Next comes the two important things. One is approach. How we can, what is the approach behind nanotechnology? We are talking about it is contributed a lot across the nanoscale. So where you can manipulate, where you can control, where you can design or synthesize, whatever it might be, you can do at the atomic scale or atomic level. So now, how we can use this technology? How we can use this technology? There are two approaches. Just generally we use it in our nanotechnology. One is called bottom-up approach. Second one is called top-down approach. Bottom-up approach and top-down approach. Let us just discuss this in a few slides. Bottom-up approach. In the bottom-up approach, different materials and devices are constructed from molecular components of their own. Materials and devices are constructed from molecular components of their own. They chemically assemble themselves by recognizing the molecules of their own breed. So basically, this is just upon adding up. It is just like a additive manufacture where the components or the products can be manufactured by adding the materials instead of removing the materials. So what they say here is, in bottom-up approach, we are going to start building the material from the bottom. Bottom in the sense they are constructed from the molecular components of their own. So you are going to get the components starting from their base. Means you start one molecular component, one molecules across the base. Then you will start adding. You just binding the each molecule across one over the other. They chemically assemble themselves by recognizing the molecules of their own breed. So when you just add the molecules from the bottom, first you're going to have molecules at the bottom layer, and first layer, next layer, next layer. So what happens here in the bottom approach, the molecules will start assembling themselves chemically by just recognizing the molecules of their own breed. So the molecules of same group, they will start assembling chemically themselves just by just recognizing their molecules. So this is how you can just build the components. In the sense, you can see here in the picture what I am showing here. So blue color, green color, this color, this color, it is a maroon. So these are all the molecules of a different breed. Different breeds have been shown in different colors. In this you can see here. Different breeds are shown in different colors. When you start building up the component from the molecule level, so you are going to get one layer of molecule at the bottom, and the next layer, then the next layer, like this. If you keep on adding the molecules at their nano levels, the molecules will start recognizing the molecules of their own breed, and they start assembling themselves chemically. Okay, so this is what you can see here, the different colored molecules. The colors will represent the type of a breed. So the colored molecules will represent they have been assembled together chemically. Okay, this is how the nanotechnology, that is bottom-up approach, is going to be used for constructing any devices or materials. Okay, examples of molecular self-assembly. So here it is, molecule will get assembled by their own. This is called bottom-up approach, where Watson-Crick base pairing nanolithography. These are the two important examples what we show. Typical examples are quantum dot formation during epitaxial groove and formation of nanoparticles from colloidal dispersion. So these are the two important applications of bottom-up approach. Instead of taking material away to make structures, the bottom-up approach selectively adds atom to create structure. This is what I was talking about. So where it is just like an addition process rather than the removal process. So how you just get the components or a products by just removing the material by a material removal process. So in this case, unlikely, in this case, we are adding the materials to get the final, just like an rapid prototyping technique, where material it is an addition process, material addition process, or material additive manufacture. So where the material is being added to get a final product. So the same thing, the bottom-up approach is also like that. Rapid prototyping is also a bottom-up approach. So it adds atom to create structures. So you are going to add the selectively in the sense. So the assembly of the components will take place themselves chemically, and they will start forming the structures. So example, they have given plasma etching, chemical vapor deposition. In the second one is top-down approach. In the top-down approach, nano objects and materials are created by large entities without bouncing its atomic reactions. Usually, top-down approach is prescribed less as compared to the bottom-up approach. So in this case, what they do, they in a top-down approach, the nano objects and materials are created by large entities without bouncing its atomic reaction. Means we are not talking about the reaction taking place across the atomic level. So, but we will going to get the objects by larger entities usually, and it is very less. We are not talking about with respect to the atomic level, how the chemically they will going to bond together or bind together to make the assembly. So this is top-down approach. We will go to discuss one or two methods of top-down approach later. So where we will go to get the materials by just larger entities, just by assembling. Solid-state techniques can also be used to create devices known as nano electromechanical systems or MEMS, NEMS, which are related to micro electromechanical systems or MEMS. So this is the one technique. Solid state technique is a basic technique for creating devices known as NEMS and MEMS, nano electromechanical systems and micro electromechanical systems, NEMS and MEMS. So solid state technique is a one top-down approach. Okay. MEMS become practical once they could be fabricated using modified semiconductor device fabrication technology, now used for make electronics. Okay. So typical examples are etching through the mass, ball milling, and application of severe plasma deformation, plastic deformation. So the typical example how you can obtain the nanomaterials by using top-down approach is etching through the mass or ball milling and application of several plastic deformation techniques. Okay. Nanomaterials are synthesized by breaking down of bulk solids into nanocells. See how you make this in this case in the top-down approaches. The materials are obtained by breaking down the bulk solids into nanocells. So means it is a material removal process like this. Just opposite to the bottom-up approach. The top-down processing has been and will be the dominant process in semiconductor manufacturing. Semiconducting manufacturing. So we use this method, and how we can get the different methods. What we can do in the top-down approaches are ball milling, solo gel method, and the this is how we can get the ball top-down approach. And quickly, I will just review for 2 minutes the challenges in technology. The challenges arising from nanotechnology is largely on target. So here No single person can provide the answer to the challenges that bring nanotechnology, nor can any single group or intellectual disciplines. However, those who know the technology best must ultimately prepare the agenda for broad discussion and participate fully in creation of relevant policy. In the realm of nanotechnology, public policy and science have become inseparable. Five grand challenges of nanotechnology. The five main challenges, quickly I will just give you this. Five main challenges are to develop instruments to access exposure to engineered nanomaterials in the air and water, and we think that the challenge will take 3 to 10 years. The emergence of new nanotechnologies, we feel that there is a very real need to monitor exposure to humans in the air and within the water. The challenge becomes increasingly difficult for more complex matters described. This is the one thing what they say the first important thing is so we need to engineer the nanomaterials in the air and water. And the most important challenge you have is the complex matters like food. The second challenge is to would be to develop and validate methods to evaluate the toxicity of engineered nanomaterials within the next 5 to 15 years. So toxicity, the poisonous. So how we can check the poisonous of these materials, validate and methods in the next first 12 to 15 years. To develop the models for predicting the potential impact of engineered nanomaterials on the environment and human health. So that to develop models for predicting the potential impact on the engineered nanomaterials on the environment and human health. What is the impact of these engineered materials or nanomaterials on the environment and human health? This is another one big challenge for nanotech challenge. The next challenge would be to develop reverse systems to evaluate impact on the environment and health impact of engineered nanomaterials over their entire lifespan. So what is the reverse effect? So we need to have to develop the systems through which we can evaluate the reverse systems which can have an impact on the environment and health. Okay. Then the last one is the fifth one is more of a grand challenge to to properly assess risk to human health and the environment. Risk for the human health. One of the most important thing what is supposed to be very careful. Okay. So I will stop at this point, my dear students. Okay. So I will going to have the class in the afternoon. Okay. So where we are going to just continue with the same thing in the 145. We are going to have it in the Google Meet only, and I will be discussing the different processing methods. Okay, and then we are going to have some more concepts regarding the nanotechnology. Okay. Have any clarification, you can talk to me because I'm just stopping at this point now. So I think we might be having the class at 9:30. Okay. So if you have any clarification, we can wind up. So you can ask. Otherwise, we will go to meet it in the afternoon. Any clarifications, my dear students? Okay. Feel free to talk to me. If you don't have clarification,